Hi, this is tutorial 2 in sample versus out of sample testing. So there are a couple of tasks we have to do. The first task is to extract historical monthly share price of Tesla with the ticker CSLA from Yahoo Finance. And in task 2, we need to calculate the monthly return of Tesla, estimate Sharpe ratio and beta of Tesla, and compare it with the market, which is S&P 500. And finally, as to use the first 3 years, 2018 through 2020, to develop a model for forecasting and then apply that model for testing the power of model in both in sample versus out of sample. So in the first step, we are going to extract data using Python. And for this purpose, we need to install related libraries. So the first library we need to install is Y-Finance, and Y-Finance is a library which helps to download the related data. So if this is the first time that you are using this library, you need to install it by the code pip install Y-Finance. In some machines, you need to put exclamation pip install rather than pip. So it depends on your machine, which machine you are going to use, and which requirements your laptop or PC ask for. So pip install Y-Finance work for me. As you see, it says already requirement satisfied and successfully installed this library for me. Since it's getting too much space, I'm going to delete the output and add the next box or cell for importing other libraries. So import pandas as PD, import numpy as MP, import date time as DT, and import Y-Finance, the new install library, as YF. All these libraries already are installed. Again, if you have not installed them, you need to install them first using pip install code. So the green tick shows that everything is running good and all related libraries are called for this task. The ticker that I need to download data are TSLA, and let me increase the size of this fonts. So TSLA and GSBC. GSBC stands for S&P 500, is the ticker for S&P 500. And then we need to determine the start time. So we need to download data from dt.datetime. So it's a function, open close bracket, 2018, February 23rd, for example. Today's, for example, let's say 25th, 24th, the last day of the working or weekday, and end is actually dt date time 2023 February 25th. So we have got the related, and then we want the prices. So prices are YF download ticker start and the interval is 1 month. So let's double check if we have got related data, and then we do other actions. Yes, the data is downloaded, as you see, and The point here is that we just need adjusted closing price, not closing, not highest price. And so we are going to extract just adjusted close price. So if you run this, we have got now just adjusted closing price. If I show you the first three rows, you will see that we have got adjusted closing price of Tesla, GSPC, and from the first months on 1st of March of 2018 up to 1st of February 23. All right, so okay, so we have got this information. The price is downloaded. The next step is to estimate the returns, monthly returns. So I'm going to call new array returns, which is equal to prices, this array, over prices, shift 1. So price in this month over the price in the last month minus 1. So calling for the calculated array, you have got monthly returns, and this is the head. So as you see, data for the first month is not available because we have got we started our pricing from 1st of April. If you want to have the April one as well, let's change the start date time. So in that case, we have got the return of April as well. All right. So simply by changing dates, you can add to the months. So in that case, so yes, I would have 61 rows rather than 60 rows, starting from 1st of February. 1st of February has missing. So one way to get rid of the missing observation is to use function. We say returns is equal to returns dot drop NA. So drop NA function drops missing the actually observations with missing values. So if I check the head, yes, so we have got now the monthly return of Tesla and market from 1st of April 2018, and it looks fine to me. All right. Yes. Okay. So now we move on. The next step is to see what has been the returns, mean and standard deviation. So returns dot describe is a function which provides the descriptive analysis of your array. So as you see, we have got 60 returns. Their mean is 5.7% for Tesla, and for market 0.007, which is actually 0.7% average return. Standard deviation 22%, and for GSPC has been 5.38%. We can say, okay, print returns mean which gives actually the average monthly return of um, Tesla and GSBC. If you want to have all of them in the, yes, so we have got the Tesla return. We can print a gap between them though. Uh, so we printed a gap between them. And also if you want to, okay, let's say, for example, instead of this gap, I can say average monthly return. And also print we can say standard deviation. We can say monthly standard deviation of Tesla's return. Can run it. So we have got monthly standard deviation here. I can say print returns std, and we have got returns std as well. The next item in the, so we have got monthly return of Tesla, estimate Sharpe ratio, beta for Tesla. So the Sharpe ratio is actually the return, monthly return over monthly standard deviation in our case. And you know, Sharpe ratio is a ratio which is used to evaluate the performance of portfolios or stocks. And this measure shows per 1 unit of risk how much return you earned. Okay, so Sharpe ratio is equal to returns dot mean over returns dot std. So the array is curated. We need to call it. Sharpe is not defined. Sorry, I did a spelling issue here. So this is the Sharpe ratio for Tesla, 0.26, and for market has been 0.14. So what this number tells me is, first of all, it says that the Sharpe ratio for Tesla is better or bigger than GSPC. It suggests that Tesla has done better performance comparing to average of market. And the reason is that per 1 unit tolerating risk, you earned 0.26 unit of return. But in case of market, per 1 unit of tolerating risk, the investors earned 0.14 unit of return. So performance of Tesla has been much better than market. The next step is to estimate the um, beta, the beta of the Tesla. So we say that we have to, the beta is actually the sensitivity of the stock to the market return. Yeah. And it's basically the slope of the line which fits the return of the S&P 500 versus the market, versus the Tesla. Basically, we are looking for answering this question, that how changes in the market, which is S&P 500, impacts on Tesla. So the best way to answer this question is to take regression. Import stats models API as SM is the package we're going to use. If you have not installed it, you have to install it first. And I'm going to define my X. My X is returns of what? GSPC, right? GSPC is our X, or independent variable or explanatory variable, and Y is returns of our favorite stock, which is Tesla, and I'm going to define a new array for independent variables containing the returns of GSPC and also intercept. Remember, we need um, to add intercept, all right? So this is X with lowercase, this is X with um, uppercase, or this is X cap, right? So X cap is SM add constant to X. Be careful, this is, again, I'll repeat myself, this is X cap, and this is lower X. Be careful about this one. And then we can do our regression. Regression is from the package SM, function OLS, ordinary least square. My dependent variable is Y. My independent variable is X cap. And do what? Fit. Once we have got this one, we can ask for print reg dot summary, and hopefully we would have our results. Let's see. Yes, so we have got OLS regression results. Dependent variable is Tesla return. The model is OLS. Least square is the method. And number of observations 60. And degree of freedom for residuals is 58. DF of model is 1. And R square is 0.25. Adjusted is 0.24, which suggests that 24.6% of variation of return of Tesla is explained by the market, but the coefficient of interest is this one, 2.08. 2.08 is the beta, and it's significant. This is a very aggressive stock, by the way. Its beta is much higher than 1. It suggests that, market changes in the market related impacts on the Tesla very much. And this is the beta of the Tesla. The next task asks to use the first 3 years sample to develop a model for forecasting. And then basically use these 3 years from 2018 through 2020 to develop your model, and then use the model to check actually the accuracy of model, both using both in sample and out of sample testing. All right, so remember, we have got returns as the array of our interest, including the basically the return of Tesla and GSPC. So now we want to divide this whole sample into 2 subsample. One of them we are going to call it training sample, and then the other one we are going to call it test sample. So training sample, using returns, we use a function. This is embedded function in the actually Python to locate specific rows in our data set. So returns.look a specific, remember here I'm going to pick up or select specific rows of my data set. All right, so that's why I used squared brackets. And look is the function which helps to separate those specific basically rows. So the benchmark to pick up a specific rows is the index. Our index is date, right? So I need to give those dates from 2018 so the first number or date in my index is 2018 03 01, column, which means up to, let's go 3 years, 2018, 2019, 2020, 2021. So although the question asked up to 2020, I'm going to extend it to 2021. And the purpose here is to have exactly like 3 years. All right. So this is my training sample and this is my test sample. Again, returns log. And this time I'm gonna select my data from 2021 04 01 up to the last available date in my array of returns, which is this one. You can basically simply copy it if you want to have an accurate spelling. So now I have got training sample from 2018 through 2021 and 2021 through 2023 as test sample. So let's see what we have got. So training sample, if I press dot, actually type dot shape, it might give me. So we have got 37 observations in our training sample, and in our test sample, we have got 23 observations. Also, you can check them if everything is all right. For example, test sample head is from 1st of April 2021 through 1st of yes, through, and can check tail through 1st of February 2023. So everything is correct. We picked up proper dates in our index of returns in order to have 2 subsamples. So one way to compare the performance of Tesla and GSPC through these periods is to type training, let's see, print training sample dot describe and print test sample dot describe. So you have got descriptive analysis of the return of Tesla and GSPC in these 2 subsamples. All right. So now the question asks to develop model using training sample. So I'm going to call it XT training sample, the same as what we did before, GSPC. The Y for training sample is the return of TSLA. We need XCAP. We use SM dot add constant to X underline T. And finally, we find out the regression. Okay, regression. We are going to rewrite our regression. Be careful. This reg is going to be over because we have got already reg. If you don't want to lose it or delete it, you need to change this title. Okay, I'm going to change it to regression. Regression is equal to sm dot ols y underline t and x cap underline t dot fit. Be careful about x underline uppercase and x cap. And finally, we are going to check if everything all right. Print regression dot summary open close bracket. Yes, so it is working. As you see, number of observations is 37, which means that we used our training sample to develop this model. And as you see, the beta has changed a little bit to 2.11, but it's still significant. And adjusted R square is 20.8%. Now we want to use this model to test basically the accuracy of the model, right? So first of all, let's do in-sample testing. In-sample testing, which means that we are going to use uh, the sample which we already used to develop model to test the accuracy of the model. Okay, so I'm gonna call this one y hat. Y hat for what? For our training sample. The training sample we show it by underline t is equal to my regression dot the function predict using xcap underline t. So because we already defined xt here, yeah. Remember, what is the xt? Let me show you before running this model. The xt is an array containing intercepts and the returns of GSPC from 1st of April to end of actually 1st of April 2021. So from April 2018 to April 2021. This is exactly the sample we used to develop model. Now we want to use it as the inputs of the model to forecast the return of the Tesla that we call it y hat. All right. So when we run this one, so we would have y hat if I just type it, and you will see that the returns of Tesla are estimated here. Okay, so now what I want to do is to put them into in the same actually data file. I'm going to call it data file one. I don't think we have had any data file with this name before. No, I have got prices. Okay, so I'm going to call it df1, data file one. So data file one using the library pandas and the function data frame open bracket. I'm going to use library bracket. I call this one actual Tesla or actual TSLA return, which was equal to YT, comma, the second one is predicted TSLA return or expected TSLA return, which is Y hat T. And df1 Okay, we have got an error. We should find out what is the problem. It says that pandas has no, yes, attribute. Always read the last uh, line of error. Usually there you will find out what is the problem. So I missed the E here, and DF1 is now here. So DF1, as you see, we have got actual Tesla return. This is the actual return, right? Minus 22%, but the predicted one is 0.004. Or here the actual one is 0.10, but here is 0.06, right? So this is the predicted based on our model. This is the actual one. Okay, so now we want to see the accuracy of this model. For the accuracy, the function that we are going to use is basically the function is from this library, sklearn. If you don't if you have not installed this library, please install it at the beginning. And from sklearn, import metrics. Metrics is a submodule in the library sklearn. We can use it. And what I want to do, I just want to make sure this library is installed first, and then, yes, it is installed in my PC, so I'm not going to reinstall it, okay? And, okay, we can put all of this stuff in another new cell here, and I can say, okay, print for me root mean square error, um, comma, which is equal to NP. NP is numpy sqrt square rt. There's a function for taking a square root of a variable. So from metrics is this submodule, find out uh, mean squared error. Usually automatically it would be show up in your collab. And so metrics dot mean square error, open bracket. So again, open bracket. What is the actual numbers? Actual returns are YT, and the predicted one is Y hat underline T. Okay, so let me explain this line of code again. First of all, print, because we want to print or the result. For any function we call, we need to open a round bracket. Root mean square error. So this is the string is going to be printed, comma. NP is the library numpys. There's a function in this library named sqrt, which actually is square root a variable. What is the variable of interest inside this round bracket again? Metrics is the submodule we already downloaded. Dot mean square error is a function which will find out the square error between actual numbers, which are the actual return of Tesla, and predicted one using our model. So as you see, the value is 0.20%. And also we can ask for mean square or mean absolute error. Sorry, mean absolute error, which is simply equal to metrics. Again, from the module metrics, we are going to use a specific function, mean absolute error, open, close. All right. So mean absolute error is 0.16 or 16.23%. So this is in sample testing. And now we are interested to know what is out of sample performance of this model. Out of sample performance of this model, which is basically we are going to use again, X test this time. I'm going to define new array. We call it X test using what? Our test sample. Our test sample. And again, GSPC Y test is equal to test sample. The related column is TSLA. XCAP test is equal to SM add constant X test, and Y hat for tests is equal to our regression result. We don't need to rerun any regression because already we have got regression using training sample. We just need to use the function predict to calculate the expected return of Tesla for the period of test sample, which is from 2021 through end of February 2023. All right, so we have got this one. Let's see if Y hat test is estimated. Okay, it is estimated. As you see, this is the expected return of Tesla for 1st of April 2021 up to 1st of February 2023. And then I'm going to put them in the same data file. I'm going to call it data file 2 just for the sake of having them next to each other. But in reality, for our purpose, we don't need even to create this data file. But anyway, so this is the, again, actual return of Tesla. I'm going to call it the actual return. Remember, it was Y test, and this is predicted return of Tesla, which is the Y hat test. Let's see if df2 is here. Yes, so we put them next to each other for better demonstration. And again, I'm going to use a scale learn in order to check and compare performance of this model in sample and out of sample. The only thing I need to do is to change here y t to y test, y hat t to y hat test, and here as well, and run this one. So comparing out of sample performance, out of sample root mean square error is 16%. Here was 20%, and MA is 0.13. Here is 0.16, which is very interesting result. And it is one of those rare cases that out of sample performance is doing better than in sample performance. Usually is reverse. In sample performance is better than out of sample performance. Anyway, that's the end of tutorial 2. Hope it has been useful for you.